Hello, good day viewers. Welcome to another mathematics presentation. So in this presentation, we are looking at how we can calculate the mean, the variance, and the standard deviation of ungrouped data. So I hope you follow through. So let's see how we can find this. So we are going to look at our first example. So the question reads, calculate the mean, variance, and the standard deviation of the following sets of data. So you can see we have A 2, 5, 7, 4, 9, B 6, 8, 20, 30, 32, and 64. C we have that, D we also have that. So we need to find the mean, the variance, and the standard deviation. Remember, this is ungrouped data. So we must know that ungrouped data, we are looking at a set of individual data points where each value is listed separately. So as you can see, here when you look at the first one, we have 2, 5, 7, 4, 9. Each of these data set is being listed individually separately, okay? So these are examples of ungrouped data. So how can we find the mean? How can we find the variance and the standard deviation? So in order for us to be able to calculate the mean, the variance, and the standard deviation, we need the formula. So since this is ungrouped data, the mean, we can come up with this formula by writing the x bar, which means the mean. So this one stands for mean, okay, is equal to, so to find the mean, we are going to find the summation of x, okay, over n. So this x is representing the data set values that you have been given, 2, 5, 7, 4, and 9. These are the values that are being represented by what? By x. Then n represents the total number, okay, the total number of data values. So in this case, for example, if we look at A, how many data values do you have? 2, 5, 7, 4. When you look at how many data values we have 1, 2, 3, 4, 5. So this means the value of n will be a 5. Okay, so how can we calculate for mean? Okay, so in order for us to calculate for mean, for the first one, we are going to use our formula, which is mean is equal to summation of x over n. So here we understand that n is the total number of data sets, 1, 2, 3, 4, 5. So n will be equal to 5. So we are going to write mean is equal to, so we are going to add these values. We are going to say 2 plus 5 plus 7 plus 4 plus 9 over a 5, okay, over a 5. Then from here we are going to have mean is equal to, so we need to add this. When we add 2 plus 5, you are going to get a 7. Then 7 plus 7, this will give us a 14. Then 14 plus 4, this will give us 18. 18 plus 9, this will give us a 27. So here we are going to have 27 over a 5. So finally, we are going to write mean is equal to, so we just need to divide. We say 27 divided by 5. 27 divided by 5, you'll get 5.4. Yeah, so this will be our value of the mean. So let us now see how we can find the variance. Okay, so how can we find the variance? So to find the variance, remember, we are going to start with our method 1, of which we are going to use a table. So in our variance, we need our mean, and we have said that mean is equal to 5.4. So in our variance calculation, we are going to use this formula where we say variance is equal to, so this is the formula, summation of open bracket x minus mean in brackets squared over n. So this is the first formula that we can use, or we can use the other formula, which is variance is equal to summation of x squared over n minus, and then in brackets we can put mean squared. So we can either use the first formula, we can say formula 1, or the formula 2. So whether we use formula 1 or formula 2, we are still going to get the same answer. So we are going to start with our first one, then we use formula 2 later on. So for the first formula, we need this table, and here we are going to put x. So under x, we are going to put the values that we had. So these are the values where we have 2, 5, 7, 4, 9. Okay, so we will write them here: 2, 5, 7, 4, 9. Now here we are going to have x minus the mean. Okay, then here we are going to have x minus the mean in brackets, then we square. So here the mean is 5.4. So we just need to say 2 minus 5.4. Okay, because it's x minus c, the mean. So 2 minus 5.4, it will give us negative 3.4. Negative 3.4. Then 5 minus, we do the same. 5 minus 5.4, which is the mean. This will give us negative 0.4. Then here 7. Yeah, 7 minus 5.4. This will give us 1.6. So here we are going to have 1.6. Then we have 4. 4 minus 5.4. This will give us negative 1.4. So this will give us negative 1.4. Then 9 minus 5.4. This will give us 9 minus 5.4. This will give us 3.6. So here we are going to have 3.6. Then here on the last column, remember we have x minus the mean squared. So we are just going to square these values that are on the middle. So we are going to have negative 3.4 squared. Okay, this will give us 11.56. So here we are going to have 11.56. So, next, negative 0.4 squared. This will give us 0.16. 0.16. Then next we have 1.6 squared. This will give us 2.56. 2.56. Then negative 1.4 squared. Negative 1.4 squared. This will give us 1.96. 1.96. Okay, this is what we are going to have. Then lastly, we have 3.6 squared. 3.6 squared. This will give us 12.96. So here we are going to have 12.96. Now, as you can see, in this formula 1, this is the one that we are using, okay? In this formula 1, we have this symbol right here on top. I hope you are able to see. We have this symbol, which is summation of x minus the mean in brackets squared. So we need to find it here, where we can write it here, summation of x minus the mean squared is equal to, so we just need to add this 11.56 plus 0.16 plus 2.56. Okay, so you just need to add those. We say 11.56 plus 0.16 plus 2.56 plus 1.96 plus 12.96. So our summation that we are getting 29.2. Okay, so we can now substitute. Okay, we can substitute on our first formula where we are going to say therefore. So we can say therefore we are going to have variance is equal to, so on top here we are going to put 29.2 over n is the number of data sets. We said there are 5, so we are going to put a 5. So variance is equal to, so we just need to divide where we say 29.2 divided by 5, and this will give us 5.84. So here we are going to have 5.84. So this will be our variance. So we have found our variance of the ungrouped data for the first question using method 1. So let's see how we can find it using method 2. Alright, so we can now answer the same question but using a different method. So we are finding the variance. Remember the second formula we said variance is equal to, we can say summation of x squared divided by n minus, in brackets we have the mean, which will be squared. So remember the value of the mean, we said that the mean is equal to 5.4. so this is our mean. Okay, so what we are going to do is, since here on top we're saying summation of x squared, the x is being presented by these values 2, 5, 7, 4 and 9. So we are going to say variance is equal to, so we say 2 squared plus, we add because we are saying summation of x squared, so we are going to square each individual value for x, then we add them. That's the interpretation here. Plus 5 squared plus 7 squared plus 4 squared plus 9 squared divided by 5, because n is equal to 5. 1, 2, 3, 4, 5. Then minus, so here we are going to have 5.4 squared. So remember, we want to see if the answer is going to be the same. So from here, what are we going to do? So from here we are going to say variance is equal to, so 2 squared it's a 4 plus 25, okay, plus 49 plus 16 plus 81 over 5 minus, so we can find the 5.4 squared. We see what we are going to get. So 5.4 squared will give us something like 29.16. Okay, so I hope that you are following through. So let's see how we can find our final answer now. So from here we are just going to add the numerators. So when we add the numerators, you get, so you say 5 plus 4, this will give us 29. So 29 plus 49, okay, plus 16, again plus 81. So we are going to have 175. So here we'll get 175 over a 5 minus 21.16. So variance equal to, so we can divide where we say 175 divided by 5. Okay, so we have 175 divided by 5. This will give us a 35. We get a 35 minus 29.16. So from here we can say variance is equal to, so we can just subtract where we say 35 minus 29.16. So this will give us 5.84. So this is our variance. So let's see if it's the same with our first one. You can see even using method 1 we found the 5.84. Again, even using method D2 we have found the same answer, 5.84. So this is how we can find the variance of the ungrouped data. Okay, so if we want to find the standard deviation now, okay, if we want to find the standard deviation, what we can just do is we are going to use this formula where we say standard deviation is equal to the square root of what? The variance. This is the formula we use to find the standard deviation under ungrouped data. So standard deviation is equal to the square root of, what is the variance? The variance we have found that is 5.84. So here we are going to say standard deviation is equal to, so just press on your calculator, you find the square root of 5.84. So when we find the square root of 5.84, it is giving us 2.41660919. So we can leave our answer correct to 3 significant figures, of which we'll say standard deviation is equal to, so we are going to have 2.42. So this will be the standard deviation. As simple as that. Okay, very simple. So we have answered our first example. Let's see how we can answer our second example. Remember, we have 4 questions under example 1. So the third and the fourth question, you are going to answer them. That will be your exercise. So we can now try to answer this one. We find the mean. So here we said mean is equal to summation of x over n. So from here we are going to add 6 plus 8 plus 20 plus 32 plus 64 over n number of data values, 1 2 3 4 5. So these are 5. So from here we are going to have mean is equal to, so we just need to add there where we say 6 plus 8 plus 20 plus 32. Ensure that you also have a calculator, plus 64. Okay, so when we add them we are getting 130. So I'm emphasizing to you to go through as well. So 130 divided by 5, this will give us a 26. So the value of the mean is equal to what? A 26. So we can now find the variance. Okay, so how can we find the variance? So in order for us to find the variance, remember, let's write somewhere. We have said the mean is equal to a 26. So in order for us to find the variance, we are going to do this. We use the formula where we say variance is equal to, so mean is equal to 26. Variance is equal to summation of, so I'll start with the method 2. Yeah, start with method 2, where I'll say variance is equal to summation of x. So summation of x squared over n minus mean squared. So this is the method that you start with. Then we are going to have variance is equal to, so we are going to square these and we add them. 6 squared plus 8 squared plus 20 squared plus 32 squared plus 64 squared over 5 minus, so the mean is 26 squared. So I hope that you are following. Then from there we just need to find the values of these. So we are going to do this. We are going to write our values down here. Variance equal to, so here we have 36 plus 64 plus 20 squared, this is a 400, plus, then we find 32 squared, that is a 1024, which is 1024, plus, then we also find 64 squared, so this will give us 4096. This is a 4096, which is 4096. So divided by a 5 minus, then here we need to find 26 squared, which will give us 676. So this will give us 676. So from here we are going to say variance equal to, let's just add the numerators. We have 36 plus 64 plus 400 plus 1024 plus 496. Okay, so you get 5620. So when we add the numerators, we'll get 5620, which is 5620 divided by 5, then minus 676. So here, our final answer, we can say, from here we can say, we are going to say variance. Okay, so we are going to write variance is equal to, so is this divisible? 5620 divided by 5 to give us 1124, then minus 676. So variance is equal to, so when we take away 676 from we say 1224 minus 676, so it will give us something like 448. So our variance is a 448. So this is our variance. Okay, so since we have found our variance, we can also calculate for the standard deviation, where I'll say standard deviation is equal to the square root of the variance. Okay, so standard deviation is equal to our variance. We have gotten 448. So our standard deviation is equal to, so we just need to find the square root of 448, and this will be 21. 21.166.0.1049. So okay, we can leave our answer correct to 3 significant figures. Standard deviation is equal to 21.2. This is our answer. So we have found the variance for this example 2. Okay, so we have used our method 1. We can try to use our method 2, which is the table, to see if you are going to get the same variance. Okay, so let's see. Alright, so under our method 2, first we are going to come up with the formula. Variance is equal to summation of x minus the mean, in brackets we square, over n. So here we have x, then here we have x minus the mean, then here we are going to have x minus the mean squared. Then from there we are going to write the values here, of which we have 6, 8, we also have a 20, we also have a 32, and a 64. Okay, so here we are going to have x minus the mean. So the x is, it's a 6. So 6 minus 26, this will give us a negative 20, because the mean is right here, which is a which is a 26. Then here we are going to have x minus 26, which is 8. 8 minus 26, this will give us negative 18. So here we are going to have negative 18. Then 20 minus 26, we are going to have a negative 6. Then there we have 32 minus 26 to give us a 6, which is a positive 6. Then there we have 64 minus the 26, which will give us a 38 right here. Then on the other end right here, you can find the squares of these values on the middle. So negative 20 squared, this will give us a 400. Then we can also find the square of a negative 18, which will give us 324. So this side you are going to have 324. Then negative 6 squared, this will give us 36. Then again here 6 squared, it will give us 36. Then we have 38 squared. 38 squared, which will give us 1444. Okay, so this will give us 1444. So after finding this, we can now find this. We can find the summation. Okay, so we can say summation of x minus the mean squared will be, so we just need to add these values, where we are going to have 400 plus 324 plus 36, again plus 36, again plus 1444. So this will give us 2240. So here we are going to get 2240. So we can now continue with our formula. We say variance is equal to 2240 over, so on top we have substituted with what we have found here, over n, which is 5, because the values are 1, 2, 3, 4, 5. So from there we can just say variance is equal to, so we just need to divide this number by 5, which will give us 448. This is our variance. Okay, so you remember, even there in method 1, we found that our variance was 448. So to find the standard deviation, we will do the same. Okay, we will do the same, where we are going to say standard deviation is equal to the square root of variance. So let's say we need to find the standard deviation. So we are going to say standard deviation is equal to the square root of the variance, okay, of which the standard deviation will also give us the same value because we have found the same thing. So here we are going to say standard deviation is equal to, so we find the square root of 448, which is 21.16601049. So our final answer, we can leave it correct to three significant figures. So this final answer of ours, we are going to say standard deviation is equal to 21.2. Okay, this is our answer. So you can see that even if we use method 1 and method 2, different formulas for variance, we are going to get the same answer. So it's up to you which one you can feel. You feel like using the one that will be very simple for you. Okay. So remember, we are using this use under and grouped data, meaning that when you are calculating for grouped data, the formulas are not the same, they are different. So let's see the exercise that you can try. So you can try to work out this exercise now. Calculate the mean, variance, and standard deviation of the following sets of data. So you need to find for this one, which is A, where you have 50, 55, 65, 70, 75, and 80. So you need to find the mean. You also find the variance and you find the standard deviation. So, and you can use any formula that you want. For B, 2, 3, 4, 5, 6. For this one, you also find the mean, the variance, and the standard deviation. Okay. So we have come to the end of our presentation. Thank you so much, everybody, for having time to view this content. This has been your presenter, Mr. Mlenga. Bye bye.